going to continue building the Lights Out game in C Sharp. I just realized I keep hitting my desk and my camera wobbles, so that's nice. Uh, but we're going to continue building Lights Out in C Sharp and UWP. And I went through, by the way, I posted our project as it stood from the previous episode. I posted that up on GitHub. There is a link in the event for this on Twitch that you can go get. I will find a better place to store that link so that you can have access to it all the time. But it's pretty easy to find if you go to GitHub and you look for Professor Krebs and you look for UWP Lights Out. It'll look like, let me see, I think I can actually pull this up for you to see for yourself. But if you go to GitHub and you look for Professor Krebs and you look for UWP Lights Out, you will find the initial project along with a gitignore file and a README. The README just basically explains what the project is and has a link to the YouTube channel where our episodes for Coding Corner are going to be archived for the long run. I've put the initial project files here. So we have our main page XAML and CS and some other important files as well. So all in all, if you hop on over to GitHub, Professor Krebs / UWP Lights Out, you should be able to get everything that you may have missed previously. So today we're going to continue with what we had previously. We're going to take that grid that we built. We built a 5x5 grid, and we made sure that we had the right colors for off and on. And I'm going to show you how we can wire up the UI elements to logical objects so that as the logical objects change, the UI changes. We probably will not finish the project today. Today's episode is going to be a little bit shorter than last time. Last time we went for about 90 minutes. This time we're going to go for about 60. But this will get us significantly closer to the finish line. Okay? Awesome. So let's go ahead and bring up our project. Also, you might notice little things like there's this commentary in the code, which basically just tells us as developers where we can find documentation on what an empty page is in this technology and so on. And then there's also this basic documentation comment. I haven't removed either of these two things because I want them there as points of reference for you if you are newer to developing in C#. At some point, I will probably remove these. For example, we don't really need this commentary, this documentation commentary on an empty page that can be used on its own or navigate, blah, blah, blah. We don't really need that. So I'm going to go ahead and get rid of that. I think I will leave line 19 here for right now in case you want to research the documentation yourself, okay? All right, so we have our two brushes, off brush and on brush. I actually remembered getting this wrong, and I had to I just changed the names of the brushes so that the colors would be in the right place. But anyway, fun times, fun times. You'll also remember that down here we have some old code that we've commented out, and it doesn't do anything, but it might act as an excellent reference later. For example, this part right here is how we show a dialog box during an event. And since this is something that does not pop up in my brain automatically like some of the other commands do, this is something I keep around for my own personal reference, and I will probably use during this demonstration. Now, first, let's get an idea of what it is we need to accomplish. So we've got this visual grid of buttons, this 5x5 grid of buttons. And the idea is that when I click a button, that button's state should change. And then the neighbors to the top, bottom, my left and right neighbors should also change. So I click a button in the middle, and then the 4 buttons around that button should also flip their state. The button I clicked and those 4 neighbors should flip. And when we're using UWP, there's this idea that you have the visual side. That's what we see in the GUI. That's the buttons, that's the score, that's the window that's on our our application is running in. And then you have the logical side. Now the logical side over here, the logical side is all about tracking state. What state? State is data. State is data about an object, or state is data about the application and what step the application is in. For example, if we were doing the game of Battleship, then we would have a state where we were setting up the boards, right? That's where we're like naming the players, and we're allowing the players to indicate how many players there are. Is it human versus computer? And then the next state would be place ships. So the players or the AI place their ships on the board, and while we're in a placement state, if we're in a place ship state, then that means that whenever I select coordinates, what I'm really saying is I want to start the ship here, I want to end it over there, things of that nature. Later, when we're actually playing the game, or if we say in progress, or if we say fight, whatever that state is, that means that whenever I select a coordinate, what I'm really doing is I'm firing at the opponent, right? So being able to track the state of the game is very, very important. Also, we could look at the state of a ship. A ship has the state of being placed onto the board, but it also has the state of being hit by certain shots. And if they get hit by shots enough times, that ship sinks. So the state of the ship could track how long the ship is, what kind of ship it is, where it's placed on the board. That's something that a ship might want to track, or that's an implementation decision, but just to give you ideas of what kind of data you could store. The type of ship, the length, how many times it's been hit, all of these three of these things are state. They're elements of state. They're data about the ship. And so what we want to do is we want to create logical objects that represent the logical state of our 5x5 grid. And then last time when we put those buttons on the screen, those rectangles of different colors, those are the visual state of the game. So we've got the logical state, right? We've got the logical state, and then we've got the visual state. And we want to not only create these two things, create the visual and the logical, but we also have to wire them together so that as the logical changes state, it has impact on the visual. Now, the way that we accomplish that in C# and UWP is that we use a feature called data binding. So we're going to create logical objects that have state, and then we're going to wire that state up to the UI objects and have the UI change color based on the logical state. We're going to do that through something called data binding. So let's look at what data binding is and how we make that happen. First things first, hop on over to Solution Explorer, and I believe in keeping a clean house. So whenever I want to make models, I also want to have a models directory. So on the project that says lights out, right click on the project and go to add folder. We want to add a new folder. I want to call that folder models. And in our models folder, we want to add a new class. And so let's call this our light class, right? So this is going to represent the light state of the button. I don't want, it's not really a light button. This is just a logical model that's going to represent a light, and that light's either going to be on or it's going to be off, which makes this class extremely simple in general. Also, please note that when you make a new class in C# and UWP, it does not automatically put the public keyword before class. And what I can tell you in C# is if it's not public, it's not public. Okay? In other words, if it's not labeled public, it's not actually public. There are different levels of scope in C#, and I'll go over those another time. But classes are what's called internal by default. So they will feel like they're public. They're not really public. So if you want these to be public, and often I do, I go ahead and I put the public keyword right there. Nice little rule of thumb. Unless you have a reason for a class to not be public, and there are good reasons why classes aren't public, unless you have a good reason why classes aren't public, you should make them public. In fact, I'm just going to throw a comment in here really quick. Unless you have a good reason that a class should not be public, a class should always be public. This is a personal practice. I would not necessarily say that this is a best practice in the field per se, but when I was in industry, that was our practice. Unless a class had a reason to not be public, it was just automatically public, which makes a ton of sense. If ever you want to export your code, or if you want to take your assembly from one project and use it like a library in another project, then having public classes is the only way to make them useful. Anything less than public in a class makes it much more restricted in scope. And so if you ever want to take your compiled code from one project and take it to another, those non-public classes will not be visible external to this code that you ported. Everything inside that code can see that class depending on its scope, but it's a guarantee that unless that class is public, then everything outside of the compiled code that you just imported, everything outside cannot see that class. So that's why we keep the classes public, so that they can be seen by the outside world. So we're making this public class light, and we're going to keep this super duper simple. I'm going to show you a really cool shortcut. Type in prop full. Now, I'm going to back up for just a second. One of my all-time favorite features in C# is the automatic property. And the automatic property is very simple. You simply type prop tab tab. And this is what happens. If you type in prop tab tab, then you end up with sort of like a template that you're going to fill in. You have a public property where you have the data type, like maybe I could do string. And then if you hit tab to go over to the My Property spot, you can then give it a name, and the proper convention is to do first word is capitalized, every word is capitalized, in other words, Pascal casing. And then you have automatic get and set. And what's really happening here, oops, sorry, I do that all the time. What's really happening here is that is the equivalent of a manual property, where if I type prop full and then hit tab key twice, then I end up with a private data field where I can specify the, I lost my place there, sorry. Where I can specify the type, like I could do string, and then I could do lowercase name to follow proper convention, and then the name of the property is capital. And notice that when I changed the name of the data field, it updated the internals of the property to match. So in other words, this property, when it calls get, will return the data field's value. And when the property is called for a set, it is going to set the data field's value to whatever was passed in. That's what that keyword value means, whatever was passed in. So this whole thing here, these 5 lines of code, are the exact same as this one line of code. It's just that the compiler is managing this and creating the backing field and generating the vanilla get and set, as you see here. It's doing all that for us behind the scenes at compilation, so that we only have to type one line of code, and then the compiler creates all this behind the scenes. However, in data binding, you are allowed to bind to an automatic property. But when you bind to an automatic property, what happens is that the binding is received, the state of that property is received one time. And then from that time forward, if that property value ever changes, the UI will never update. It'll never update. And the reason is because there's no what we call change notification. In order for that change to be reflected in the UI, there needs to be change notification. In other words, the property has to say, hey, just so you know, my value changed. And then it informs the UI. The UI says, oh, okay, your value changed. Based on your value, the UI is now going to look like this. So we have to have change notification, or the UI will never know that the logical side changed. But automatic properties, while they are bindable, do not have change notification built in. We don't have that built into automatic properties, but we can easily add change notification to manual properties. So let's hop over and let's not use this automatic property. You can keep this as notes if you want, so you know what an automatic property is and how to create one. But we're going to use a manual property, and we don't really want name. I'm going to get rid of all this really quick. We're going to try this one more time. Prop full tab tab. What we really want is a Boolean, a bool that expresses whether or not the light is on. And the property will be of the same name, except it will be a capital I versus a lowercase I. This is convention. Data fields are camel cased, meaning that they start with a lowercase letter, and then every subsequent word starts with a capital letter. Whereas properties and methods and classes are all Pascal cased, which is that they start with a capital letter, and every subsequent word also starts with a capital letter. This is convention, so that we know that we're talking to a property that is marshalling a data field behind the scenes. So we have this property, great. The next thing that we need in order to add change notification is that we're going to implement an interface. And when we implement interfaces in C#, we start with a colon right next to the class name, and then the name of the interface itself. In this case, I notify property changed. Now, when you first do this, even if you spell this correctly, you're going to get a red squiggle worm of death. And the red squiggle worm of death is an error that says, hey, when I went to compile this, it didn't make sense. And if you look, it says, hey, the type or namespace known as I notify property changed could not be found. And then very intelligently, Visual Studio, and I sometimes imagine that it's saying this in a sarcastic or snarky voice, are you missing a using directive or an assembly reference? This is absolutely correct. We are missing an assembly reference, or actually it's a using directive. So really easy way to fix this. We can either click on show potential fixes, we can hit Alt Enter, or my personal favorite, Control Dot. Control Dot is my friend because Control Dot does a lot for autofill and fix suggestions and things of that nature. We want to add the using statement for system.componentModel. And you'll see it appear up here. It's kind of hard to see, but you might notice that several of these usings are in gray, and this one using has a brighter blue using and it's all in white, that sort of thing. The reason this is brighter is because there is code that utilizes something in this namespace. Whereas these grayer ones, like these two up here and the three beneath, they're present by default because they're commonly used, but currently there is no code that actually uses these namespaces. So if I were to right click in the middle of nowhere and I were to say remove and sort usings, it would actually get rid of the usings I didn't need and alphabetize the ones I did. In this case right now I've only got the one. I'm going to back up. I'm going to Control Z that because I might yet still use something in here. And so I don't necessarily have to get rid of all those. All right, so now we've brought in the using statement that lets us use the iNotify property changed interface. However, you will notice that it still is in an error state. It's changed color to let us know it's an interface type, but it's still in an error state. And when we hover over that, you will see that it says light does not implement interface member and then property changed. Remember that whenever you have a coding interface, I'm going to hit F12, by the way. I'm going to hit F12 to go to the definition of iNotify property changed, because an interface defines members that a class must have if it implements that interface. In other words, iNotify property changed guarantees that any class that implements iNotify property changed will have an event of delegate type property changed event handler called property changed. In other words, the interface guarantees this exists in the class. Well, if we hit Control minus to go back to where we were, you'll notice that in Light, there is no event object. There is nothing called property changed. So we have not implemented this interface, or rather we haven't implemented members of the interface. Really fast way to fix that, Control dot, implement interface. And if you do that, you'll notice a new line of code appears, public event, property changed event handler, property changed. Now, I'm going to just bump that up here to the top because I like my events to be at the top of my class. It's a preference thing. I like these things to be at the top. In fact, I'm going to take this manual property, highlight it, and then holding the Alt key, I'm going to press the up arrow to shift where this thing is located. Because it's a real property with a real field, I want it closer to the top. Again, this automatic property, if you want to keep this around for notes, that's great. Otherwise, you don't need it. Personally, I'm going to get rid of this. All right. So now, let's see. All right. So now we've got property changed as an event. If you don't know what a delegate is, I'm going to give you a very short explanation. I don't want to get too deep into this right now. It's the kind of thing you could research on your own and you could understand. And it's a super cool topic. And it's one of the reasons that I love events in C# as much as I do. I've done events in Java, I've done events in C#, and I've played around with events in some other systems. I love C# events because they're so robust and they're so easy to work with. Events in Java are sufficient, but the way they're designed requires you to implement an interface per class so that they can talk to each other. A subscriber can talk to a publisher correctly. And there is a way to make an anonymous type based on that interface, but then you have an anonymous type object. And it's a little bit more clunky in Java. It's sufficient, it works, and you can do it very quickly, but it's not as clean, robust, and it doesn't require you to redefine a class type just so that it can interact with a publisher. Instead, you can simply have a method, and that method talks to the event, right? Or rather, it's invoked by the event. So here's the idea. Imagine for a moment that you're the manager of a team, okay? You're the manager of a team, and your boss is going to tell you when it's time for your team to run a drill. Now, they know how to run the drill. Each member of your team has a job during the drill, but they don't know when to go. And you don't know when to go until the boss tells you. So you are waiting for the boss to tell you it's time to run the drill. Then that time comes and the boss says, okay, team lead, that's you, team lead, run the drill. You then go to each of your teammates, each of your underlings, and you say, it's time, do your part. Then you go to the next teammate, it's time, do your part. Then you go to the next teammate, and you do this for all of your teammates, right? They are now doing their job during the drill. And some of them may have a very similar or even the same job. Some of them may have extremely different jobs. But they know it's time for them to do their job because you told them it's time to execute the drill. And you knew it was time because the boss told you. It wasn't you going to the boss saying, excuse me, boss, is it time to do the drill yet? No? Okay. Is it time to do the drill yet? No? Okay. Is it time? See, that process in code where one object is asking another, is it time yet? Is it time yet? Is it time yet? That process is called polling. And there are places and times where polling makes sense. But most of the time, especially in GUIs, we don't want all these objects asking a few objects if it's time yet, if they've changed, is the state different? We don't want that constant action going on because it's really expensive to ask those questions over and over and over again, 60 times, 120 times, 1,000 times a second. Instead, it's much better if the boss can just come to you when it's time. So if the boss comes to you because it's time, then you know it's time to run the drill. You don't have to constantly ask. What we've just described there is called event handling. Instead of you asking the boss, is it time, is it time, is it time? The boss tells you, hey, it's time, go. And that go command is an event. We're saying this thing has taken place, now take action. And then you are going to go to your team and say, go do your job, go do your job, go do your job. That model right there makes you what's called the delegate. Or rather, you are the object that delegates when it's time to work, when it's time to go and do. So the way we set this up in code is that we're going to create a delegate that allows other objects to subscribe to that delegate. In other words, that's how they become the teammates. That's how they say, hey, when it's time, you can call this method and I'll go do my job. Okay, so that's subscribing. So your teammate subscribes to you. That makes them the subscriber and you the publisher. You're the delegate. Okay. Now in C#, delegates are super cool, but they're also super brittle. In other words, they're easy to break. Because it's very easy to tell a delegate that they're just null, and then suddenly all subscriptions are gone, and no subscriber knows that they've lost their subscription. There's no warning. There's no notification. So in C# we have something called events. Now events are objects that wrap delegates. And they function exactly the same way because they act as a go-between between the subscriber and the delegate. That way, the subscriber cannot tell the delegate to be null and to break. The event protects the delegate and only allows friendly and non-destructive interactions. So that's just me verbalizing this concept of, we have a delegate's wrapped by an event, and objects are going to subscribe to the event, right? They're going to subscribe to the delegate through the event. I can describe that, and that's great, but it's better to see it in action, and it's better to see it in code. So this event, see that keyword? It's beautiful. This event wraps a delegate of type property changed event handler. If I hit F12, I'm going to go to the delegate definition, and the delegate defines what kind of methods can subscribe to the delegate. A method that wants to subscribe to this delegate type must return void and must have a parameter list that takes in an object first and a property changed event args object second. As long as you have a method that returns void, takes in an object, and a property changed event args in that sequence, then that method can subscribe. Not a problem. And this delegate is called property changed event handler. I've often found that when I say there's a handler, I'm often referring to the method that reacts to the event. So I apologize if the vernacular gets kind of swapped around. But this object, this delegate, this is you. This is the team lead, right? And now it's just waiting for teammates to say, hey, it's time to do the drill. So this delegate is established. If I hit Control minus, it will take me back to where I was. Oh, nope, never. Oh, that's because I did some things with my mouse. But yeah, it'll take me back eventually to this light class. And now we have an event that wraps a property changed event handler delegate. So that means that if anyone wants to subscribe to this event, they have to return void, take in an object, and take in a property changed event args object. Now we are going to see this in action in just a little bit. I just want you to understand the basics of what this event is. And the short story is, this object is going to track methods in other classes so that when this is told to go, when it says, hey, my property changed, then this event is going to tell those other classes, hey, execute your method, my property changed. All right, so we have this event in place. The next thing is, whenever I have this method in place, I like to make a helper method, a private helper method. It's just private void, and I like to call it field changed. Or if we want to be a little bit more in line, then we might want to say property has changed or something to that effect, right? Which sounds kind of Boolean, and I'm not sure. And I don't want to just say property changed, because even though it's a method, it can easily be confused with the delegate, even though they have a slightly different call pattern. I mean, even right here, if you hover over this, it says, hey, we already have something called property changed. I wish you wouldn't do that. So I'm going to call this field changed. Okay. Now, field changed is going to employ this nifty trick that became available in more recent versions of C#. I believe it was actually C6 that introduced this feature. But you can have a caller member name attribute. I think that's what it's called. String name equals null. And I like to put a little space there, sorry. Now, we got this red squiggle worm. If we do control dot, we will get a using system.runtime.compiler services. If we add that using, this annotation, this decorator becomes active. And what this says is, whatever member of the class invoked this method, called this method, I'm going to take the name of that thing and I'm going to store it in this variable. Now, this doesn't make a lot of sense just yet, but you'll see it in action in just a moment. Because over here in the isOn property, I'm going to just bump these down. And after we change isOn to whatever value this is, we're going to call field changed without passing anything in. Now, if you're used to C#, if you're used to calling methods, you'll see that we're invoking the method, but we're not passing anything in, even though this method has a parameter of type string called name. We're using, first of all, we're using something called default parameters, which means that if nothing is passed in, then we will simply assign to this parameter whatever value this is. In this case, I'm assigning null, which is kind of a weak default, but it's very useful in this case. So we're making this thing automatically null if they don't pass anything in. But remember, we also have this decorator. And what's super cool about this decorator is that when isOn calls field changed, the name isOn is going to be captured by this decorator. And the decorator is going to essentially do this. It's going to say, oh, that's the value of name. That's what you want name to be this time when you called me. So it's going to set name equal to isOn. I'm going to change this back to the default. The default doesn't really change. It's more like it would be the same thing as if you said this. If you said isOn as the first line in this method. Now, of course, we don't want it to always be isOn. We don't want it to always be isOn. We want it to be whatever member of the class called this method, because maybe this class ends up with multiple properties. So whichever property calls field changed, the name of that property will be stored here in the name field. The reason we're storing the name is for the next step. First, we are going to, I'm going to do this the long way and then I'll show you the short. Whenever you have an event, you want to first check to see if that event is null, because if it is null, that means there are no subscribers, and if there are no subscribers, you take no action. However, if it's not null, that means you have subscribers. So first, check to see if you have any subscribers, and if you do, then invoke the event to notify the subscribers of the change. So what that looks like is when I talk to this event, I'm going to call property changed dot invoke, and I'm going to pass in the current object itself because it wants to know who's the sender. Well, the sender is the light. The light is the sender of this event. So we're going to say this, or rather the current instance of light. And then we're going to make a new property changed event args object, and that object wants to know what was the name of the property that changed. So remember, this decorator captured that name for us, and it stored it in this variable. So all I have to say is, it's whatever's stored in name right now. Now the reason it does that, and this is super cool, this is again one of the reasons I love events in C#. They've really utilized the property changed event very well. The idea here is, instead of creating a different event for every possible property that could change, they create one event, and that one event can handle every property that changes in that object. Because when that event fires, we're going to tell that event which property changed. And based on which property changed, it's going to go through its invocation list and tell only those subscribers who care about that property that the value has changed. So let's say for a moment that I don't only have an isOn property, but I also have a temperature property, how hot the light is. If isOn changes, then every subscriber who cares about whether the light is on or off is going to get notified. But every subscriber who cares about the temperature of the light, they're never going to know. They're not going to know if it turned on or off because they don't care. They don't get notified about that, even though technically they're subscribed to the same event. This is super cool. Usually events have one function, one purpose, and it's to monitor the state of one property, and it'll notify you about that one property. But this kind of event, this structure allows us to have one event that can manage every property, and it's only going to notify the subscribers who care about that specific property, which is totally cool. It makes our code so much slimmer. So here is on. It's a data field. We can't bind to that, but we can bind to this property. And this property is going to utilize field changed. Field changed is going to invoke this event if there are subscribers. And when it does invoke this event, assuming that there are subscribers, it's going to say, hey, this specific property changed. Now, this right here, this line of code right here on line 36, this is our change notification. Remember earlier how I said in data binding, in order for data binding to work, we have to have change notification. We have to have a way for the logical element to tell the UI that the state has changed, and so the UI should update, right? In order for that to happen, we have to have change notification. That's what line 36 is. Line 36 is change notification. Now, I told you that this would be the long version, right? And this is the long version of the code. In fact, I'm going to comment this out just so that you can see it. Because with the advent of C#7, they gave us this really cool operator that allows us to check for null while we're invoking code. So the property that the problem that we have is that the property changed event could be null, which is why we check to make sure it's not null first before we call .invoke. Because if I call .invoke on a null object, I'm going to get a null reference exception. I'm going to break the application. But in fact, if you don't mind, I just retyped all this, but I'm just going to grab this right here. I'm just going to drag it down here. I made a copy. By the way, I held control. So I highlighted first, held control, did a drag, and that's a copy. So using my control trick, using my control trick, I copied that line down here. Now, right now, if I do this and there are no subscribers, I will throw an exception and break the app. But if I add a question mark, in C#7, this is a new feature. This is, we're going to invoke using the null check operator. This operator says, hey, I'm going to make sure this is not null first. If it's not null, I will go ahead and continue invoking. However, if it is null, I will simply return null. So, if property changed is null, this call will automatically, hang on a second, let me spell that right, automatically return null instead of throwing a null ref exception. In other words, this whole body of code right here, this block of code that does the check first and then invokes, is exactly the same here. The only difference is that this will return null, whereas if this if check comes back false, it simply doesn't do anything. It doesn't execute this code. It doesn't return anything. It's just false and it doesn't execute. This will actually return a null value, but as you can see on the left-hand side here, no one cares. So it can return null and no one cares. So this one line of code will do everything we need it to do. Yes, I realize now that my method looks super fat, but really, this is the only line of code that does anything. Our method is effectively this, and that's a beautiful thing, right? C# is super cool. It's super hot, and it has all these really cool developer-centric tools like the null check operator and caller member name annotation or decoration that makes our lives as developers so much easier. All right, cool. Now, the last thing that we need that we're missing from our light is we need to have some way to toggle, right? We got to have a toggle of some kind. So I'm going to do public void toggle. Now, we also have to, we have to have this notion that we want to toggle with notification. We want to toggle without notification, right? So let's do the following. Let's do toggle, and we will do a Boolean with notification, and on top of that, we will default this to true. Now, when we do, here's another parameter with a default value, a default parameter. That means that when I call the toggle method, I can either call toggle without passing anything in, or I can choose to pass in a bool of my choice. Either way will work. And one of the cool things about default parameters is that cuts down on the number of overloads. It used to be the case that if you wanted to have a method that took in a Boolean, or if you wanted to have one that did not take in a Boolean but did the same thing, you would name it the same thing and just use a different parameter list. And then this is what's called an overload. But I was in industry in cases where I had one method with 15 parameters, another method with 8 parameters, another method with 5 parameters, another method with 4 parameters. And the ones that had fewer and fewer parameters simply assumed default values for the missing parameters. Later on, they introduced the idea of default parameters, and it made it so that you didn't have to write an overload again necessarily. There are still cases where you have to write overloads, but for the most part, you don't have to anymore. Again, another achievement for C#, right? Yeah, I know other languages do that too, but C# added that feature, and I almost wept with joy. Let me warn you about something if you're new to code. If you're new to code and computer science, I'm going to tell you right now, the more you do it, and the more you study, and the more you learn, the more computer science completely changes your brain. And what you think is cool and fun and sexy, all of that changes entirely. In fact, I teach at a college. I teach computer science at a college. And one of my students who just got done with his first full year, right? I had him when he was a first quarter student, and I said this to the entire class. I said, computer science changes the way you perceive cool, funny, and sexy. And there will come a day when you're like, that's sexy. And you're referring to code, okay? And the thing is, you'll mean it. I'm not joking. You will find code that like legitimately turns you on intellectually, all right? But the point is, that student, during his fourth quarter, right, the end of his first year, I showed him a feature in C#. I think it was the null check operator, actually, and how we were able to reduce that if statement to just one line of code. And he looks at me and he goes, Mr. Krebs, that is some sexy code. And he's like, I finally get it. I get what sexy code is now, right? C# has a lot of sexy code. So I'm warning you now. All right, so we have this toggle. And the reason I put this notification in here is because sometimes we want to toggle it so that there is change notification involved. And sometimes we don't. Sometimes when we're setting up a puzzle, for example, we want to make sure that we're calling toggle where notification is false, or where with notification is false. So we're going to make this version. Now, it's true that as we build out code, sometimes I'll look at this and I'll be like, you know what? I don't really like this design. Let's redesign this. That's okay. That's just a refactor. We can do that, right? But for right now, I think this is probably the best approach. And so if it is true that we have with notification set to true, if with notification is true, then let's set the property is on to equal not is on. And that means since we're using the property, it's going to call the setter, and it's going to set the value of is on to the opposite, and then it's going to call field changed, right? This part right here is where we call the opposite value. However, if this is set to false, it means that we want to toggle our state without causing a change notification to occur. So that means we're just going to bypass the property entirely, and we'll just say that we're going to set the data field to the opposite of itself. Yeah, I use the property here, and that means that there's like an extra step behind the scenes when in fact I could just get away with doing lowercase I, but I want to be consistent here, and I believe firmly in the principle of if you have a property, if you have a getter and a setter, use the getter and the setter. Except in this case, we can't use the getter and the setter because we don't want to accidentally fire off this line of code, right? So in this case, we want to bypass change notification. So we're going to do that by changing the data field directly. And here we want to utilize change notification. So we're going to set that value using the property. Okay? All right. So now our light object is set up. Now, this is going to be interesting. Let's hop over here to our code behind. Remember, in our code behind, we set up all these rectangles, right? And these rectangles are visual elements that appear on the screen. You might recall that if we execute this application, it's going to bring up a UI where there's this whole grid of squares. Oh, it's taking forever on mine because it's been a while since I executed this. Come on, where are you? I feel like it's trying. There we go. And so here is, woo, sorry. Yeah, I gotta shrink. Sorry. So it went to a different screen on my laptop, and so it's just utterly huge. That's better. All right, cool. So here are our different buttons. Here's our 5x5. In fact, I think I'm gonna constrain the window size in the future. But here's our 5x5, and each one of these rectangles was put on the screen using this double for loop. Right? If you remember this, or if you weren't here last episode, that's how we did it. This double for loop creates a rectangle, paints it, sets a little bit of spacing here, this margin, so that they are separated in a reasonable way, and then tells that rectangle where to be in the grid, and then adds that rectangle to the grid's children. Now, the other thing that we want to do here is we want to data bind that rectangle to, in fact, you know what, just in my brain, the way I see this, let's instead set the binding up right here. Yeah, to be honest with you, it doesn't really matter the sequence of things, but I'm trying to put this in an organized fashion so that the thought process makes sense. So yeah, right here, so here we've built the rectangle with some of its stats. And now we want to build a new light. Now, right now, that namespace, that model's namespace is not present. So we're going to create this line of code. You'll see the red squiggle worms of death. Let's go in here and let's do control dot. And then we have lights out dot models. That's the namespace that this class is in, right? All right, cool. So now we've got this new light object. Our lights, you know, that's an interesting point. Let's make sure that our lights start in that they default to the false position. Now, technically, bools start by default in the false position. But I'm one of those guys that believes in when in doubt, code it out. And some people may not realize that this is in the false position to start. So I want to make sure that it's clear, it's explicit that it starts off false. And so here is our new light, and it's going to be false. Great. And then we're going to create a new binding object. The binding object is a third object that sits between the rectangle and the light so that it can communicate when those objects should change. In other words, normally when we bind a UI element, let's see, I was doing UI over here, right? When we bind UI elements to logical elements, we want to have two-way communication so that as the UI changes, it can tell the logical object to change. And as the logical object changes, it can tell the UI to change, matching the changes made, of course, right? And so the way that happens is that there is a third object in the middle called a binding object. And that binding object facilitates the communication between the visual element and the logical element. Now, we don't always need two-way communication, and in this case, we don't need two-way communication. Yeah, we're going to be clicking on the rectangles, but two-way communication would be, I'm going to change the color of the rectangle, and that's going to force the logical object to change its Boolean. Typically, what's going to happen here is that we're going to change the Boolean, and that's going to impact the color of the rectangle, and that's the only way that communication is going to travel. Even so, we still need a binding object in between to facilitate that communication. It can facilitate two-way communication, but we're just going to need the one way from the logical to the UI, okay? So we're going to create this binding object, and I'm just going to call it light to rect binding. And I'm purposely giving this a long name so that you know what the purpose of this object is, okay? And we're going to say new binding, Now, a binding needs three things in order to do its job, okay? It needs to know, first of all, what's the data source? What is going to be the logical object that I'm watching so that I know where the data is coming from so I can inform the UI, okay? So first, it needs a source. Second, it needs a path. Because often when we have a source object, it's not the entire object that we want to bind to. It's just one thing about that object that we want to bind to. In this case, we have an instance of light, but it's not the entire light that we care about to change the color of the rectangle. We only care about whether the light is on or off, right? So we only care about the is on property. We don't care about the whole light object. For the binding, we only care about the is on property. So first we need a source, that's the light object. Then we need a path, right? The path is the property on that object that we care about. And then finally, we need a mode. What kind of communication are we going to be using? Is it one way? Is it two way? That sort of thing, okay? So in our binding, we need to set our source. And the way that we normally do that, there are a few ways you can get the source. You can either set, let's see, we have binding dot, sorry. We need light to rect binding. So we get the instance of binding, and it has a source property. And that will take in any object we want. And I could set this to light. I could say, all right, well, source equals our new light instance, right? I could do that. For several reasons later in life, whenever we're doing data binding in UWP, source is okay if you want to be very specific down to the nitty-gritty, and there's no chance of any shared data from a source object. Or rather that, imagine for a moment that you make an application for contacts, for managing contacts, right? So you have like name and phone number and email. Well, you might have a single object for contact, and that object is going to have its name first and last. It's going to have email. It's going to have phone number. That contact object is going to have several points of data that different elements in your UI are going to want access to. And I could set that single instance of contact as the source for each individual binding. I could do that, but that's not the most efficient way. Especially when you're talking about a form that may have 20, 30 fields. I mean, it kind of just depends on how much information you want, right? And so it's not always wise to have, you know, every binding object has its own source, because it may be that you want the same source for several binding objects. Now, we have to have a source, but that source does not have to be from the source property. It ends up that there's something called data context. And every UI element has its own data context. It has the ability to track sort of like, I don't want to say a global object, but you can have an object that is set up as the data context for a UI element that has many child elements. And when you have a data context for a parent, it trickles down to the children automatically. So for example, if I had a stack panel that had all of my form inputs for what a contact is, I could set the data context of the stack panel. And if I put the contact as the data context for the stack panel, then that contact is the data context for each of the child elements inside the stack panel. And that way, I don't have to set the source for every data binding. If there's not a source set, it will look to the nearest data context. So I want to practice doing that because that's actually the better way to go 95% of the time, okay? So this is what that looks like. Instead of setting the bindings source, we are going to say, hey, look, and again, you could do this in any order. I'm just trying to make this logical. I could say, hey, rect, so this UI element, this rectangle, has a data context that points to our light object. So in other words, our light object is going to be the data context for the rectangle and every child inside the rectangle. Yeah, in this case, we're not really going to have children or anything like that. But again, I want to show you best practice as it applies to the common scenario. And using data context of your UI element is the better practice 95% of the time. All right, so we've got our data context set. That means that our light to rect binding, we don't need to set the source at all. We don't need to set this. I can't even type that out right now because it thinks is trying to do autofill, but we don't need to set the source because the source is by default going to be the data context of the rectangle. Next, we do need a path. So let's talk to our light to rect binding dot path, and let's make it equal to a new, it's property path, I believe. There we are. Where we tell it what's the name of the property that we want to use. And in this case, if we go back over here to light, the name of our property is on with a capital I. So we want to, as a string, put is on. What we're doing here is we're saying, hey, look, when it's time to do the binding, go to the source object, either in your source property or the data context, and I want you to find a property on that object called is on. Finally, we have light to rect binding dot mode. This is going to be the mode of communication, and it's of enum type binding mode, and we want one way. One time means I'm going to bind this once, and no matter how many times is on changes, I'm not going to tell you, rectangle. We obviously don't want that. Two way is, okay, if the color of the rectangle changes, I will flip the Boolean. If the Boolean changes, I will flip the color of the rectangle. Now, we're not going to have a case where the rectangle's color changes before the logical object does. So we don't need two-way. We really just need one way. That means when the light changes its state, the rectangle will change its color. And that's the only way this binding goes. And that's actually going to work in this case. So now we have our data context object, our logical representation, and it's set as the data context of the rectangle, and we have our binding object to bind the light to the rectangle, and then we set the rectangle in the grid, and we add it to the grid's children. Okay. Now that we have all that, I could tell you that, hey, magically everything's going to work, and the truth is it's not yet. We're still missing a couple of things. First of all, we need to handle what happens when the rectangle gets clicked. When the rectangle gets clicked, what should occur? Well, we should tell the light to flip its state, and we should do the toggle with notification. However, there's another interesting problem. We've now bound the light to the rectangle, but what we're going to say is, oh, wait a second, I take that back. We haven't done the binding yet. Hang on. The last thing we need to actually do here is we need to actually say, hey, rectangle, set binding. We have to actually tell it, hey, you need to use this binding object. Now this is where it's going to get a little weird, but this is one of those times where I say, trust me. It wants to know which property of the rectangle depends on the light. And so we're going to say rectangle as the class, give me the property for your fill. In other words, fill property. This gets really weird to explain. So let me explain it very briefly. Fill property is a property that returns an object called dependency property that represents the fill, this thing right here, right? It represents this property on the rectangle. In other words, this is a property that returns an object that represents this other property. Yes, I know that's weird, but the binding needs to have that object so that it knows how to talk to this property. So yes, it's a property for an object of a property. I get that. But don't spend too many brain cycles on that. All you need to know is we're saying, hey, rectangle, tell me how to access the fill property. That's what this is doing. Okay? So we want the rectangle's fill property to depend on the light's is on property. And then finally, we're going to put a comma, and it wants to know what binding object to use. Well, which binding object did we make? We made that binding object. So I'm just going to go ahead and do a copy drag, right? So I copy it, a control drag. So here we have set the binding, okay? So what we're saying is that the fill, the color of the rectangle, depends on the Boolean is on state of the light. But that poses a new problem. A Boolean can only be true or false, right? It can only be true or false. However, the fill of a rectangle is a brush, and that brush needs to be a color. Well, a Boolean is not a brush. And we just said, hey, fill of the rectangle, I know you need a brush, but you're going to depend on this Boolean to get that. How do we get a Boolean to be a brush? We need something called a value converter. Now, we're out of time today, so we're not going to be able to cover that. But if you want to get ahead, excuse me, I'm so sorry, a little hiccup there. If you want to get ahead, go ahead and research value converters or iValue converter, the interface, in UWP. That will give you an idea of how to take a Boolean and magically turn it into a brush. All right. Now I'm going to go ahead and post this code up on GitHub. I'm also going to experiment with branches so that episode 1 has its own branch and episode 2 has its own branch. But the master trunk, the master branch, will always have the most current code. All right. So with that in mind, pay attention to the GitHub. I will be updating the code there so that you can see where we are and what we have, and you can join us next time. Next time we'll get into value converters and we'll start clicking on the rectangles to see how they change their neighbors, and we'll set up all those events. You guys are awesome. I always appreciate you. Thank you very much for being here. And until next time, remember, be epic, don't suck.